or section 12.5. Where we're going to talk about the z-score percent table for normal distributions. These numbers are hard to read. They're very small. I understand that. We're only going to talk about this a little bit. It's not that difficult because it's pretty easy to read. Okay. If I have a z-score equal to 1, what is the percentile that's in? Okay. So up here, I see my z-scores. Oops, I forgot to activate my pen. I have my z-scores are here and here and here. I'm looking for a z-score of 1. Okay, so I'm looking out here in this outside column, and I come down here and I can see that 1 is right about here. Okay, and I look at the two values. I've got 1.03, which is 3 100ths away from 1, and 0.99, which is 1 100th away from 1. So I'm going to go with the one that's closest to 1 right there, and it's the 84th percentile. Okay, so z-score of 1 is an 84th percentile. Remember, 1 is positive, so that's going to be to the right of the mean or the median. Okay. What about negative? I guess I can write that. Well, no, that doesn't make any sense. What about negative 1.175? Well, again, I'm going to look over here at my z-scores. Negative 1.175. That is actually right on here at 12. Okay, so you just find the z-score on the table and apply it to the percentile, which is in the column next to it. Any problem that you have on your homework will give you this table if you need it, or they'll give you a portion of the table if you need it. Okay, remember the z-score is found by taking the data item minus the mean divided by the standard deviation. Okay, so let's do this example right here. Okay, lengths of human pregnancies are normally distributed with a mean of 266 days with a standard deviation of 16 days. What percentage of the children are born from pregnancies lasting more than 274 days? So remember, we're going back to this thing. The data item is 274. Subtract the mean, which is 266, divided by the standard deviation of 16. So I've got 274 minus 266 would be 8 divided by 16, which equals 0.5. Okay, so then what percentage of the children are born from pregnancies lasting more than 274 days? I'm going to come back here and find 0.5, which is right up here. 0.4959 and 0.52. 0.4959 is closer, and you can see that it is the 69th. So how many pregnancies last more than that? Well, 31%. Okay. What percentage of children are born from pregnancies lasting more than 274 days is, well, everything below this or less than that is the 69th. So we take 100 minus 69 and we get 31%. The next part, finding the percentage of data items between two given items in a normal distribution. We need to convert each data item to a z-score, and then we'll talk about what we do. Okay, so the amount of time that a self-employed Americans work each week is normally distributed with a mean of 44.6, standard deviation of 14.4 hours, and what percentage of self-employed in the United States work between 37.4, that's one of them, and 80.6 hours per week. I need to find the Z-score for those two, so I got the Z of 37.4 equals 37.4 minus 44.6 divided by the standard deviation of 14.4. Grab my calculator. $37.4 minus 44.6 divided by 14.4, and I get negative 0.5. Okay. Then let's do the second part of it, where our second Z-score of 80.6 is 80.6 minus 44.6 divided by 14.4. And I'm going to grab my calculator again. And 80.6 minus 44.6 into divide 14.4 is 2.5. Okay, once I have my Z-scores, I need to find the percentages that go with those. Okay, so I'm going to come up here. I've got negative 0.5. I'm going to go up to my table here. Negative 0.5 is right here, 31. And then 2.5 is off the charts. 2.5 is not on this one. I know that it is 99.7, I believe. Sorry, I did not realize that this chart did not have that value on it, but we'll go with 99.7. So what percentage is between those? I take the 99.7, subtract 31, and I get 0.78, and 68.7% of them are between there. Okay, that's it for this section. So one section left and we are golden. Again, if you have any questions, please email me. We can Zoom, we can answer questions over email, whatever it takes. Thank you.